Hello, I'm Tarsa, and this video is a guide on how to make non-vanilla Mario Kart Double Dash characters. In this video, I will be taking a model of Detective Baby Rosalina from Mario Kart Tour and putting it into Double Dash over Baby Mario. This video will assume that you have some basic skills, namely, how to open a GameCube ISO file, how to pack and repack ARC files, how to unpack zip files, and that you already have some basic knowledge of Blender or 3ds Max. As a disclaimer, I don't know Blender that well, so the way that I work with that program is not necessarily optimal. mram.arc, which is located in the main directory of the game, contains many important files. The driver folder within this archive contains all of the character model files. In this folder, each character has their own subfolder with a driver.bmd model file and facial animation.btp files. Some characters also have drifting bone animation.bca files. Obviously, editing a character model file will affect the file size of mram.arc. If mram.arc is too large, then the game will crash when loading a course. Thus, making sure that the file size of your character BMD is not significantly larger than vanilla is important. In Double Dash, all model files are BMD files. In order to show the setup of a typical Double Dash character BMD file, I will display the Baby Mario BMD in a BMD viewing program called ReStudio, created by Reedify. First, there are two materials, one for the body and one for the face. They are separate so that the facial animations can be applied to only the face. You will also notice that there are two textures for each material, a main texture and a highlight texture. It is highly recommended that the materials in your character use these vanilla materials. Then there is the skeleton. All characters follow the same basic skeleton. One quirk of Double Dash character skeletons are the four pause bones directly under the root bone. These bones are essential and need to be in your character or all the bone animations will be messed up. While this is not directly displayed, each vertex in this model is skinned to exactly one bone. This is typical for Double Dash, but can be broken to a minor extent. Then there are two meshes, one for the body and one for the face, just like the materials. There should be at most one mesh for each material so that driver effects like invincibility are applied correctly. Finally, there are the textures. There is a body texture, various face textures for the animations, and the highlight texture. While the body and face textures can and should be changed, the highlight texture should be kept vanilla. The first step to making your own character file is to convert the vanilla character file into a more usable format using SuperBMD. SuperBMD is a command line tool currently maintained by Yoshi2 that can convert common model formats to and from BMD. Batch files make using command line programs like SuperBMD a lot easier. For conversion from BMD, I will use this bat file. The contents are simple. I will just be calling SuperBMD on an input file. When I run it, SuperBMD will identify the file as a BMD file and automatically convert it to day. The output of this operation is all the textures in the model with bitmaps, a day model file, and two JSON files that define the material and texture setup of the model. These JSON files will be essential when converting back to BMD. Bitmap textures are progressively smaller versions of a main texture. In characters, they are simply the main texture shrunk down by half on both height and width. The shrinking continues until the height or width of a texture is 8 pixels. Bitmaps are used when the camera is far away from the model. This improves performance as the game does not have to load a full-size texture all the time. However, one side of using them is that they increase the file size of a texture by 33%. All vanilla character models use bitmaps for the body and face textures. For this reason, the usage of bitmaps is recommended in cases where without them, the file size of a character is less than vanilla. However, in cases where using bitmaps would increase file size significantly above vanilla, they should be omitted. If not using bitmaps, delete the _mip files that SuperBMD outputted. This character, with an above average number of faces in its model, will not be using them due to initial file size concerns. Double dash characters have body texture sizes of 256 pixels by 128 pixels. The body texture for this model has already been edited to be 128 pixels by 128 pixels. This will help account for the model, which has more faces than vanilla Baby Mario. The typical face texture shows only half of a face because the texture will be mirrored. The texture this model came with has the full face. I cut this face texture in half down the middle to save some space. I also reduced the size to 32 pixels by 64 pixels. You may need to re-UV map the model to accommodate this change, depending on the source model and textures. All textures should have dimensions that are powers of 2. This is to enable the usage of bitmaps and so that the textures can look correct on console. All textures in a character model should be at most 256 pixels by 256 pixels. Rename your textures so they match that of vanilla. This will make conversion back to BMD easier. If relevant, create new textures for blinking and other emotions. For this model, I only created new textures for blinking. Doing this limits the range of emotions that the character can express, but also reduces file size. When choosing or creating your model, it is important to end up with a model that fits the skeleton of an existing character. While it is possible to edit bone animations, doing so can be a very tedious process and thus is not recommended. Additionally, for file size reasons, your model should not be too high poly. Vanilla characters tend to have around 600 to 800 faces. You may need to optimize models that come from other games, especially if they came out anytime during or after Double Dash's release. First, get your non-vanilla model into 3ds Max. If you need to import it, go to File at the top left, Import, Import again, then select your model and click on Open on the bottom right. Now edit the material names so that they match vanilla. You can do this by opening the Slate Material Editor, selecting the material to be renamed, then typing in a new name in the upper right-hand corner. For most characters, this is their mrem.arc folder name, _all_tx for the body, and their mrem.arc folder name, _i_tx for the face, but you should check with your individual character. In this case, the material names start with BB Mario as opposed to Baby Mario, so I rename the body material to BB Mario _all_tx and the eye texture to BB Mario _i_tx. The normals in a model affect the direction at which light is reflected off of it. When all the normals of a mesh are broken, light may be reflected in unexpected directions, and the lighting might not look smooth across the surface. This can cause the different faces to be distinguishable. When the normals are unified, the directions continuously change across the surface of a face, so light is reflected evenly across a surface. The effect of this is that the model appears smoother. Vanilla Double Dash character models use a material that causes them to reflect light. This, plus the low poly nature of the models, causes normals to have a huge effect on how characters look in-game. Edit the normals of the model by adding an Edit Normals modifier. To do this, look at the drop-down menu in the top right corner and click on the down arrow. Select Edit Normals from the list. Then select the normals to be unified. Now click on the Unify button, or select the checkbox for using a threshold and then click on the selected button right above it. Depending on the model that you are using, you may want to leave some normals broken. To break normals, select them and then click on the Break button. When you are done editing the normals, right-click on the box in the top right corner with the modifiers and click on Collapse To or Collapse All. Remember to do this for both meshes. In 3ds Max, import the day file from the output of SuperBMD. Make sure that the units are specified as meters. This is going to import the skeleton that will be used to skin your model. Then, add a skin modifier to the body model in the same way that the Edit Normal modifier was added. On the right, locate and click on the Add button next to bones. In the pop-up, select all of the bones in the scene except for skeleton_root. Then, click on the Select button on the lower right-hand corner of the pop-up. Now, assign vertices to bones. First, click on the Edit Envelopes button at the top. Also, check the checkbox for Select Vertices. 3ds Max will automatically skin the model for you, but it is never good. On the right, scroll down until you see a square button with a wrench. This is the Weight tool. Click on it and a pop-up should appear. Scroll back up on the right to the list of bones. To assign vertices to bones, select a bone from the list, then select the vertices in the viewport, and finally click on the one on the top right corner of the pop-up. I will only be assigning one bone to each vertex. Assigning multiple bones to each vertex is possible, but can cause crashes and should be avoided whenever possible. I will upload a separate unscripted video linked in the description of me skinning this model in 3ds Max. During and after skinning, clicking on a bone on the right will cause the vertices weighted to it to turn red. For the face mesh, add a skin modifier, but only add the face_1 bone. This will automatically weight all vertices to the face, because the face bone is the only one. Most of the time, this is what you want, so no further work is needed. To export, select the meshes and skeleton only. You can use Ctrl-A to select all visible items. Then, go to File, Export, Export Selected, and export as FBX. I keep the scale automatic and the Y up versus Z up doesn't matter. Unfortunately, the output from SuperBMD looks weird in Blender. Luckily, there was a workaround. Blemd is a tool written by Nyack Dorial that allows BMD files to be imported directly into Blender versions prior to 2.8. I am using Blender 2.79. To install Blemd, unzip the blemd-master zip file and rename the folder inside to Blemd. Then, copy that folder to only one of these 4 folders on the screen. Out of these options, I copied the folder into addons_contrib. In Blender, go to File, User Preferences, and a pop-up should appear. Click on the Add-ons tab at the top, and then on the Testing option on the side. Check the checkbox for Import GC/WE BMD format. Click on the Save User Settings button on the bottom left of the pop-up so that you can use Blemd on Blender Startup in the future. If you have not done so already, delete the cube, camera, and light that Blender generates. Then, import the vanilla driver BMD. To do this, go to File, Import, then select the option at the bottom for Nintendo BMD/BDL files. The model will be untextured and the material names may be slightly incorrect. If you wish to work in a future version of Blender, export this as FBX. Make sure that additional bones are not generated by going to the Armature tab on the bottom left of the Export dialog and making sure that the option for Add Leaf Bones is unchecked. For the rest of this part, I will use Blender 3.0, which is the latest version of Blender at time of recording. In Blender, import the previously exported FBX if needed. Then, import your own model. Edit the material names of your model to match vanilla. In Object Mode, select a mesh. Then, click on the red checkerboard symbol at the bottom right corner to show the material properties. Here, there is a text box where you should put in the vanilla material name. Blender will automatically smooth normals. This option can be found by clicking on the green triangle to access the object data properties and then expanding the normals category. Due to inexperience with Blender, I did not edit the normals in any way. Rename the driver armature object to skeleton_root. This is necessary for converting to BMD using Super BMD. Go into Object Mode to add the skin modifier. Click on the blue wrench symbol for modifiers. Then, click on the Add Modifier drop-down list. Choose Armature from the top of the Deform column. In the Object field, choose skeleton_root. Then, go into Edit mode. Click on the green triangle and expand the Vertex Group section, which should be the first one. Assign vertices to groups by selecting the vertices in the viewport, selecting or creating a group on the right, and then clicking on the Assign button on the right. New groups are created by clicking on the plus button on the upper right corner of the section. Assign groups to bones by naming groups with the exact same name as the bones in the skeleton. Groups can be renamed by double-clicking on them in the Vertex Groups list. The order of groups in the list does not matter. Finally, export from Blender as FBX, again making sure that the option to add leaf bones is unchecked. Because I am not going to be using bitmapped textures, I have to edit the textheader.json file to accommodate this. For each texture that used to use bitmaps, which in this case is all of them except the highlight texture, I set the bitmaps field to 0, the min filter field to just linear, and the max flood field to 0. Replace the name of each unreplaced texture with the name of the main face texture. I replace bb_mario_i textures 3 to 6 with bb_mario_i texture 0. Because the material and texture names match those of vanilla, no further alterations need to be done. To convert to BMD, create a bat file that looks something like this. What this bat file does is call Super BMD on an input file with an intended output file name of driver.bmd and specifying that the material and texture setups as defined in the JSON files should be used in the generated BMD. Just drag the FBX file onto the bat file and the driver BMD file will be created. Common errors include typos in the JSON files, a lack of a root bone called skeleton_root, not all vertices being weighted to a bone, and texture specified in the text header JSON not being found. This driver.bmd file is 55 kilobytes, 10 kilobytes less than the vanilla Baby Mario BMD. This is mainly due to cutting down on the textures. At this point, I could add back bitmaps, add more facial expressions, or increase the body texture size, but for now I will keep it as is. This is because I want to do a cart edit in a second video, and I want to leave enough space in mm.arg for that. Repack mm.arg with the edited driver.bmd file and put it in your extracted file system. I always test in time trials first because it is less prone to crashes and I can see the character in action without having to worry about computers. Then I test in Gran Primo just to see more animations. If these look good, I do one last test on console. This video only covered the biggest part of a non-vanilla character, which is the main new character model. I will try to make another video that goes over all of the auxiliary parts of making non-vanilla characters. If you have gotten this far, thank you for watching the video. I wish you the best of luck with making your own double dash non-vanilla characters, and I look forward to seeing them on the wiki. I would like to thank Yoshi2, Goomba NL, and Trainiacs for helping with the video. I would also like to thank everyone who watched a rough draft of this video. I will be providing links to them in the description.